All right, so hello, my beautiful people. We are here today to look at the popular but interesting topic of functions. And before you ask me what grade it is, I mean, there it is in your face, son. In your face, son. All right, yeah, in your face, son. That's what it is. Okay. So what is it that we are actually going to be checking out as we go through this video? Well, we are going to look at what a function is, of course, the definition of a function, all right? And just briefly, just from the exam guideline, what it is that you must be able to know when it comes to functions. So hopefully you guys are really geared up and excited for what is to come. Here we go. Okay, let us read together. You need to know, as per the 2021 exam guidelines. All right, guys, remember 2021 exam guidelines, they are actually the guidelines that basically stipulate what it is that is required in the exam for topics in mathematics. Remember, the exam guidelines for all subjects, but specifically the exam guideline as it pertains to functions says the following. 1. Candidates, which are you guys, must be able to use and interpret functional notation. Candidates must be able to use, so you must be one that can use, and you must be able to interpret functional notation. Now, even as I say this word, hopefully you know what functional notation is. Okay. In the teaching process, learners must be able to understand how f of x has been transformed to generate f negative x. Do we all know what this actually is referring to? When we say f of negative x, when speaking about the transformation, all right, do we understand what f of negative x, what transformation in your function that refers to? Secondly, negative f of x, do we understand what the transformation is referring to here? F of x plus a, do you understand what implication does that have on the transformation of a function? F of x plus a, do we understand? Okay, as it relates to the addition of a dot, meaning a multiplied by f of x, do you understand that? And then lastly, x is equal to fy. Do we understand how and what transformation that is speaking to? Where a meaning a here, a there, and a there are elements of real numbers. Do we understand what that refers to? Well, this is exactly what we are going to be unpacking, because candidates must be able to use. How can you use something that you don't know and interpret what functional notation, right? And then in the teaching process, learners must be able to understand how f of x has been transformed to generate, how this gets transformed to generate that. So the question is, what is the transformation process from this to that? What gets affected? How does it get affected? Same thing from that to the second one. What is affected? How does it get affected? Same from this to that. What is affected? How does it get affected? From this to that. What is affected? How is it affected? from this to that, what is affected and how is affected, and then from this all the way to that, what is affected and how is it affected. I'm going to look at all of that. Here's something else to note. In the new curriculum, as per the exam guideline 2021, when the curriculum had been introduced, the emphasis is on investigating. What are you investigating? The effect. The effect of what? The parameters. What parameters? A, B, P. A, there's A, there's A, there is A, there is A. B, okay, there's no B here, no B there, no B there, there is B. P, there is no P, there is P, there is P, and there is P. And Q for the following functions. There is Q, there is Q, there is Q, and there is Q. For the following functions: linear, parabola, hyperbola, and exponential. So I'm just going to ask you guys to tell me right off the bat, what function is represented by this form? You can comment for me in the comment section. If you're in grade 11 and 12, in fact even a grade 10 and a grade 9 learner would be able to tell me, what form is this function called? We call this a what function? Malibongwe maponya, straight line. Gazi, linear. Simo, straight line. Tinanduna, linear function. Okay, guys, thank you so much. Let me the word linear is formal. The word straight line is a good alternative. So these are two terms that are synonymous. You can either call this a linear function or a straight line function. So you guys are 100% correct. I'm proud of you. Right, let me segregate this. What do we call this function? And maybe you can also tell me what form of this function is this, and what is the alternative form that this function usually appears as. Malibongo says parabola. Tina says the same. Gazi is saying the same. Daludo is saying the turning point of the parabola. Tina says parabola. Red Lotus says exponential. Andile K is saying turning point form. Right. Malibongo is saying parabolic. Simo is saying parabola. Okay, guys, the majority of you, I'm going to without mentioning who, but I'm hoping the person that said exponential can sort of see why we do not regard this as exponential, but rather we say this is a parabolic function or a parabola. That's fine. Parabolic, parabola, or we can say quadratic function. Parabola, quadratic function, that's fine. Okay, so parabola and quadratic are synonymous. Okay, then the form that we have here is what we call the turning point form. There is an alternative equation that is used to represent a quadratic or a parabola form in grade 11, and I want us to explore that form. So this form specifically is used and is called the turning point form, or they call it the vertex form. That's an alternative word that they use. You can either say it's the turning point form or the vertex form. So turning point form or vertex form. That's one way in which your quadratic function is represented. But that is not the only way a quadratic function is represented. It can also be represented as y is equal to ax squared plus bx plus c. Okay, yes, this is the turning point form, definitely. That's why I put TP, all right, to basically indicate that it's turning point form. Or you could say the vertex form. That's a synonymous word that means turning point. This other second form is what we call the quadratic form. The quadratic standard form, to be more specific. Okay, ax squared plus bx plus c. All right. Okay, and I know some other learners will even say, there is this form as well, sir. A into x minus x1 into x minus x2. Some will call this the x-intercept form, or I guess you could say the root form. Okay, so I hope, guys, we all understand that now. So for your parabola, you have three possible forms: your turning point form, your quadratic standard form, or your x-intercept form. Okay, three different forms that you can potentially see your parabola or your quadratic function being represented as. Let's move on. What do we call this form? What do we call this function? This one. What do we call this function, guys? Tinanduna, hyperbola. Tinanduna is like tinnering it up, hey? Tinnering it up like crazy. So melez and bongwana. Andile K. I see all people. Yeah. Okay, very good, guys. You guys are 100% correct. It is called your hyperbola. There is the word that refers to this form. I think it was a hyperbolic function. Okay. Then last but not least, this last form that you see here. Y is equal to ab to the power x plus p plus q. What do we call this function? Grade 11 and 12 is the grade. Yes, Tinanduna, exponential. Okay. Exponential function. Very good, guys. So this one is this one, and this one is that one. Okay. Okay, just something else to note. The concept of the inverse of a function is also emphasized in the grade 12 syllabus. It is important for you learners to realize that the graph of the inverse of a function may or may not be a function. Okay? It is important, as they are saying, for learners to realize that the graph of the inverse of a function may or may not be a function. It might be necessary to what? To restrict the domain of the original function. And the reason why domains get restricted, and now we are specifically referring to the parabola. Parabola is not necessarily a function. The inverse of the parabola is not necessarily a function. And when it is not, it becomes necessary for us to restrict the domain of the original function so that the prevailing inverse function can actually be considered to be a function. Now some of you are like, "Hey, Bosa, are you trying to say that the inverse of a function may or may not be a function. Yes, and I'm saying yes, that is the case. Okay. Mfana kagogo, okuhle, there it is. Mfana kagogo is saying, okuhle, if you don't mind, I can help you. So, Mfana kagogo is there to mfanarize. Nonhle shozi as well is asking for help. Mfana kagogo. So, Mfana kagogo be a true mfana kagogo, and mfana kagogo, the people please. What does restrict the domain mean? Red Lotus, that's a very good question. One I'll be answering very well when I go into the specifics, but the short of the answer to your question is, do you even know what a domain is? Yeah. For instance, if you are going to restrict, let's just speak of something general. If you are going to restrict TV time for your kids, you must first know what a TV is. Because when you decide to restrict TV time for your kids, it means that first and foremost, you're going to have to know that, okay, in this TV that you are talking about, okay, what is the TV? And therefore, how do you then go about restricting television time for your kids? Understanding exactly, of course, what a TV is. Because you'd have to switch off the TV and all of these things, which is very important. We're going to look at that. So domain, guys, is the possible x values where a function exists, right? We are going to look at the specifics of restricting the domain. So what we usually do is we restrict the domain. I'm going to look at that for you guys so that you understand that, and it's clear. It will be clear for you by the time we are done. What is a function? A function is defined as a relation between a set of inputs, and by inputs, guys, we are specifically referring to our x values having one output each, and by outputs we mean the y values. In simple words, a function is a relationship between inputs where each input is related to exactly one output. Every function has what we call a domain and a codomain, but the word codomain is not a popular word that we use. We use range, all right? Because if you're talking about your functions, you're going to have an x and a y value making up points which, when connected together, basically form your function. Okay, a function is generally denoted, or it is shown by f of x, okay, where the x here refers to the input value, where x is the input. That's why I was saying the set of inputs is your x values. So f of x denotes, or basically refers to, a function. Okay, yeah. So of course we've just learned that the types of functions we have are linear. So this y can be replaced by f of x instead of just having the y there. Okay, many y values, one x value. Yes. Can I ask, is a function can also be seen by many y values and only one x value? Many y values, one x value? No, can't be. That is not a function. Okay. Yeah. And I'll be unpacking that for you guys. But that is not a function. Tinandun. Yeah. Yeah. That is not a function. So we'll look at that, the specifics. Keep it up, man. Good work. No problem. Yeah. So we'll look at those specifics. But that is not the case. Okay. I know you guys have a lot of questions, but if you can allow me to unpack things one by one, we'll be fine. So let us look at then some what we call key content aspects a learner must master in functions. These are the things that you need to master in functions. 1, determining the coordinates of the intercepts with the axis. Okay, the coordinates of the intercepts with the axes. So there are 2 axes. You have your y-axis. All right. So this on your Cartesian plane is what you call your y-axis. Then you also have your x-axis. Okay. This is your x-axis. The equation of the x-axis, since it's a horizontal line, is y is equal to 0. The equation of the y-axis, since it's a vertical line, is x is equal to 0. So when you want the intercept of the y-axis, what do you do, guys? Let me ask you. If I want the intercept, remember the word intercept means cutting through. It's when you are cutting through, passing through, overlapping, or crossing a particular line, which is the y-axis. So if we overlap, cross, cut through the y-axis, and we want what we call the y-intercept with the intercept with the y-axis, what do we do? Yeah, very good, guys. Since the y-axis has the equation x is equal to 0, any vertical line has the equation x is equal to a particular constant. This particular one, the y-axis, has the equation x is equal to 0 because the vertical line is 0 everywhere on the y-axis. So we call it the line x is equal to 0. I repeat this again. The y-axis is the vertical line that cuts through 0, the origin. Right? So since that is the case, the x values on this y-axis are 0 everywhere on this vertical line. So when we want the y-intercept, we let x be equal to 0. Then the x-axis, when we want the x-intercepts, what do we do? All right. When we want the x-intercept, the intercept on the x-axis, what do we say? Very good, Tina. Bontle, very good. We let y be equal to 0. So when we do that, we let x be equal to 0, then we solve for y. Remember, when we write down, because they are saying we need to be able to determine the coordinates. When you write down the coordinates as your answer, guys, you need to then be able to see that, okay, it was me letting x be 0, meaning that the x coordinate will be 0. The resulting value will be y. Okay, but of course you are going to specifically give that y value and put it in the place of the y coordinate. If you let y be equal to 0, please, then you need to make sure that when you write down the coordinates, 0 is basically y, and then the x coordinate, the resulting x coordinate, you will place in first place for your ordered pairs. This goes back to this. You need to know how to determine the coordinates of the intercepts with the axis. 2, you need to be able to determine the equations of the asymptotes. I want to ask you this question. What two functions have asymptotes out of the 4 functions that you have? Remember, we said these are the 4 different types of functions. We have linear, hyperbola, parabola, exponential. Which one has asymptotes between these 4 functions? Which ones have asymptotes? Gazi D is saying hyperbola. Okay. Tinanduna is saying parabola and hyperbola. Okay, I'm allowing you guys to answer so that at the end I can clarify. Bondle is saying hyperbola. Iconic Black just shared the live. Thank you very much. You are so iconic in every single way imaginable. Gazi D, maybe, and exponential. Iconic Black, yeah, parabola. Nontle, exponential. Tabza, hyperbola. Bondle, parabola. Which, and the question was saying, which functions possess a asymptote? So now we are going to know. Linear, no asymptote. Linear function doesn't have an asymptote. Hyperbola, yes. How many asymptotes? 2 asymptotes. Always 2 asymptotes. Your hyperbola has 2 asymptotes. There's a horizontal asymptote, which is usually given by y is equal to whatever the q value is. And then there is a vertical asymptote, which is given by x is equal to whatever the inverse of your p value is. 2 asymptotes for your hyperbola. So you guys that said hyperbola has asymptotes, you are spot on. Parabola, does it have an asymptote? The answer is no asymptote exists for a parabola. The sad and the happy face don't have limits. Sorry, not limits. They don't have an asymptote, okay? So parabola has no asymptote. Exponential, yes. There is one asymptote for an exponential function, and that one asymptote is simply the what? The horizontal asymptote, which is usually given by y is equal to whatever the q value is. Now some of you are like, okay, what does this even mean? Q value, the inverse of p, right? So now when we talk about asymptotes, we are going to zoom into the hyperbola function and the exponential function. If you go to the forms of the function, here is your hyperbola. I said the horizontal asymptote resonates with the value of q. The horizontal asymptote for your hyperbola will resonate with the value of q. So if I'm going to write down the equation of the horizontal asymptote, I'm going to say y is equal to whatever the value of q is. That is my horizontal asymptote. Okay, then 2, you have your vertical asymptote. What is the vertical asymptote? Your vertical asymptote will be x is equal to whatever the inverse, whatever the additive inverse is for this particular constant value. So if I have, let's say, plus 3, let's say in this place of p there was a plus 3 alone, then I would say that the equation of the vertical asymptote is x is equal to not plus 3 but the what? The inverse, the additive inverse of plus 3, which is what? Thank you, Bondle. The inverse of plus 3, the additive inverse of plus 3 would be negative 3. So therefore, like Tina has just written down, 100% correct, I would say x is equal to negative 3, and that would be my vertical asymptote. Beautiful. Beautiful. I love you guys. The way you guys follow along. Really appreciate it. Now let's come back now to the exponential, because we saw that with hyperbola we have two asymptotes, the horizontal one, okay, and when they sketch it in your graph, it's usually like broken lines that are horizontal. Then you label whatever that broken line that is horizontal, you label it y is equal to the specific value of q. Obviously, you're not going to say y is equal to q. That's just a general, representation of the horizontal asymptote. You would specify the value of q. So if it's, let's say if there's a 5 here and it's positive, we'd say y is equal to 5. If there is a 3 here that it's negative, we'd say y is equal to negative 3. But then for the vertical asymptote, we say x is equal to whatever the inverse of the p-value is. So if you have plus 3 here, it means x is equal to minus 3. If you have 8 here plus 8, then it means x is equal to negative 8. If you have minus 3 here, then you would say x is equal to positive 3. So it's always the inverse, the opposite of the constant term that is represented there. Then for our exponential function, the exponential function only has one asymptote, one and only one. Okay? And that horizontal asymptote is given by the equation y is equal to whatever the value of q, we are here in this function, this is our exponential function, whatever the value of q is. Okay, that is your horizontal asymptote. You fly with this. There's only a horizontal asymptote. There is no vertical asymptote for an exponential function. So once again then, to summarize, the two functions that possess a hyperbola, that possess an asymptote, are your hyperbola, it has two asymptotes. Your exponential function has only one asymptote. Arnold, I am uploading my videos on YouTube, sir. The two videos that I've done, or the two live lessons that I've done so far, are already uploaded. They are there. Okay, I may have maybe just adjusted the time, done a delay in the post of the most recent live lesson I did. So yeah, and I'll be obviously uploading this as well. Okay, now, so determining the equation of the asymptotes, these are things that you must master. Guys, you must master these things. Okay, how to determine the coordinates of the intercepts with the x's, we've just discussed that. We know what we need to do. You must know how to determine the equations of the asymptotes. Okay, you know how to do that. We are coming to that. Can Sir explain how to determine the domain? We are coming, guy. Wait, please. 3. Okay, you guys need to follow the sequence so that I can explain everything. All right, so allow me to focus on what I'm on so that it can get its deserved full explanation, and then we can move on to the next concept. Okay, just be patient. I know we want to know everything all at once, but let's calm down. Breathe in, breathe out, go to your gift gallery, select a rose, and then send it, and then you'll see. Determine the equations of the axis of symmetry. Okay, now here we need to know how to determine the equations of the axis of symmetry. This is plural, guys. Equations. Oh man, thank you so much. I really appreciate it quite a ton. The only one, Lebowski. We've got the doc. Yeah, I think I'll call her the doc. Thank you so much. I really appreciate the rose. Determine the equations of the axis of symmetry. Now, I'm going to ask this question. Which functions have axis of symmetries? Do we understand what an axis of symmetry is? In fact, guys, just before I go there, do we understand what an asymptote is? Guys, an asymptote is simply a boundary. It's a boundary line where your function doesn't exist. It's almost like you in your life you have boundaries, right, as well. And those boundaries, they basically set and determine the regions in your life where you are most likely to be found and not found. All right, things people should do with you and they cannot do. Those are boundaries. So asymptotes have boundary lines, which we call your functions, your hyperbola and your exponential function have boundary lines, and these basically define where the function is supposed to exist and not exist. But exactly on the boundary line, the function does not exist. Okay, so we need to always be mindful of that. What is an asymptote? It's a boundary line where the function doesn't exist. Next, we are supposed to be able to determine the equation of the axis of symmetry. Okay, a line of symmetry, guys, it will usually cut something into half so that you can see a mirror image of the other half on the other side. That's what a axis of symmetry does. It cuts something into half so that you can see a mirror image of the other half on the other side, all right, of the line of symmetry. So determine the equations of the axis of symmetry. Which functions do we usually see having axis of symmetry? Okay, which ones? Gazidi, parabola. Okay, Gazidi is saying parabola will possess an axis of symmetry. Okay, is that the only function that possesses a axis of symmetry? Hyperbola as well. All right, thank you so much, guys. You guys are you guys. Zoe, let's be careful about that. Exponential, no. Bondle, hyperbola, very good. So guys, the one that will possess equations, meaning plural, will be your hyperbola. So hyperbola, okay, will possess an equation or axis of symmetry, an equation of the axis of symmetry. Hyperbola, there's two of these axes of symmetries. Okay, right, one that possesses a gradient of +1 and the other one possesses a gradient of -1. So there is a positive gradient straight line and a negative gradient straight line. That is your axis of symmetry for a hyperbola. Then a parabola also possesses an axis of symmetry. There's only one. It is vertical and it has the equation x is equal to. That x is equal to is actually, guys, the x coordinate of the turning point. So that x value, or the equation of the axis of symmetry, which is vertical, okay, is x is equal to whatever the x coordinate of your turning point is. Okay, non-clear shows what is happening here. Please, what's the please for? Okay, can you repeat what you have said? What do you mean what I have said? What specifically, what are you referring to? Okay, there's no ways I'm going to go back and repeat from the beginning what I've said. Unfortunately, you're going to have to catch that from the live lesson. But if you are speaking specifically on the point that I was talking about the equation of the axis of symmetry, I can repeat that. Okay, I can definitely repeat that. Okay, the axis of symmetry part. Okay, no, it's fine. The thing you need to know as a learner when you are on your way to mastering functions is you need to be able to determine the equations of the axis of symmetry. And I was saying that a axis of symmetry is simply a line, all right, that cuts through your particular function in such a way that it divides it into half, so that one half is a mirror image of the other. That's what the axis of symmetry does. So for your parabola, we have one axis of symmetry which cuts through the turning point. In actual fact, it vertically cuts through the x coordinate of the turning point, but it cuts through like the whole entire vertical, all right, so that you can see mirror images of the other half. So it's like, for instance, if you're looking at this function, this is y is equal to x squared, this is the parabola. So in this case, the y-axis is a vertical axis of symmetry. So we would say x is equal to 0 is the vertical axis of symmetry for this parabola, okay? Because it is the vertical line that does what? Divides the function into half, so that this side, you are seeing the mirror image of this side on the other side. And that's what an axis of symmetry is for your parabola. Then we said the axis of symmetry is not something that only you see in a parabola, but you see it on a hyperbola. And there are two axes of symmetries where your hyperbola is concerned. There is a increasing gradient straight line of your axis of symmetry, which has the gradient m is equal to 1, always has the gradient m is equal to 1. And then there's another one that has a gradient that is negative, which is always m is equal to -1. And you can see by the way in which your straight line, the direction in which it goes. This is a negative gradient straight line, whereas this is a positive gradient straight line. And so in the grades that you are doing, 11 and 12, our gradients always take on either, if it's a positive axis of symmetry, it will have the gradient +1. But if it is the negative gradient axis of symmetry, it will have a gradient that is -1. And this, guys, is always the case, right? You can never go wrong there. Never ever go wrong. We will look at the other specific details, but it just is important for now for you to know that there are two axes of symmetries in your hyperbola, which you need to be aware of. One has a negative gradient, the other one has a positive gradient, and the specific equation we are going to look at. Parabola has only one axis of symmetry, and it's a vertical line that cuts through the x coordinate of the turning point. So therefore the equation of that vertical axis of symmetry will be x is equal to whatever the x coordinate of the turning point is, okay? But we'll be looking at details, guys, when we go into the stuff. What's important for now is for you to have a sense of recognition that, okay, if ever I'm asked to find the equation of the axis of symmetry, which functions would be applicable? And we'll look at the how and the what, the specifics. 1, 2, 3, 4. These determine 1, 2, 3. These are some of the questions that get asked specifically. You need to be in the position of knowing what it is that is expected and then what to do. We are going to get into the how, obviously. This one says calculate. You need to know how to calculate the coordinates of the turning point. Okay, guys. Yeah, you are going to have to be patient. All right, I know you want me to explain all of that stuff, exponential functions and more, and how to use log. Those things I'm going to get to eventually. I may not necessarily be able to get to them today, but this is a series, in lessons that I'll be doing. I've started today, so you need to follow along in the series. I'll post what I've done so that if you missed anything, you can follow. You can go to my YouTube channel, look at the video and follow along. But in the next lesson, which is tomorrow, I'll be continuing wherever I decide to leave off, and I will cover every aspect. So you need to just patiently tag along with me. Allow me to hold your hand and to walk with you one step at a time without being rushed, and care more about making sure that your bucket is clean, it is empty, there is no cracks, potential cracks that will make the water that I'm trying to pour seep through. You need to care about the retention of the knowledge. Retain the knowledge I will impart to you, especially though the knowledge you already have, which I'm just clarifying. Some of you already know the things I'm talking about, and what is going to happen now as we go through the sessions, I'm only going to solidify the knowledge and clarify so that you don't have misconceptions about what should be expected from you. So allow me to tag along with you and to walk with you, but be patient with me at the same time, because I need you to be, so that I can get through certain aspects that some people are like, yo, I've been waiting for this explanation. Right? I don't want to shortchange the experience for others in the name of wanting to rush for others. So thank you so much. Really appreciate it. And Doc, oh my goodness, Doc is like pouring the roses there. Thank you for 16 roses. I really appreciate it. Now, we need to know how to calculate the coordinates of the turning point. Now, very quickly, we learned that there are two forms of the parabola function. Two. The first form is the vertex form, or the turning point form. Y is equal to a into x plus p, the whole thing squared, plus 2. That form will help us to determine the the coordinates of the turning point. This form, when we want to get the coordinates of the turning point, we know that we get the x coordinate where? From inside this bracket. How? Take the bracket, the expression inside the bracket, equate it to 0, and get the inverse of the p-value by solving, ensuring of course that x is positive, having a positive coefficient. Take the p over, you get x is equal to negative p. What is my x coordinate of the turning point? It is negative p. Y, the y coordinate, is the q value as it is. So that means the y coordinate of the turning point would be q. So that is being general. The turning point is read from the turning point form. That's why we call this the TP form, the turning point form, or we call it the vertex form. There's no need for serious formula calculations here. Take the expression inside the bracket, equate it to 0, solve for x. That is the x coordinate of the turning point. This is also the equation of the axis of symmetry. Hence I was saying to you guys, this x coordinate coincides with the axis of symmetry, because once you put x and equate with the x coordinate of the turning point, you have the equation of the axis of symmetry. Okay, that's why I was saying one vertical axis of symmetry for your parabola. That is one way of getting the turning point if you have the what? If you have the parabola given in the turning point form or the vertex form. So the sign of the p-value always changes. Yes, the sign of the p-value will change. To be more specific, guys, please take note of the expression inside the bracket. Sometimes they trick you guys, and then they put inside this bracket negative x plus something else. The x is not positive, but it is negative. Hence I say the safe thing to do, always take this expression, equate it to 0, and solve for x as you normally would. Remember, if the x coordinate, the variable x has a negative sign, After taking the p over, let's say it was negative x plus 2. You would say negative x plus 2 is equal to 0. Take the 2 over, you get negative x is equal to negative 2. Then divide both sides by a negative to get the actual x value for the turning point, the coordinate. So always, I would say, and I would advise, take the expression, equate it to 0, whatever it is, okay, the entire expression inside the bracket, and then solve for what? Solve for the x coordinate in that way. Also, the y coordinate of the turning point, it's always q exactly as it is, guys. If this is plus 3, it's plus 3. If it's negative 7, it's negative 7. Whatever the sign is of the constant. 2. What if the function is given in this form? Now, I know some of you are like, then sir, you know, in grade 11, I learned at the beginning of the year, term 1, that you can actually do something called completing the square of the expression. And I can convert this form to this form. And guys, you are 100% correct. You can, right? Because that would be a way to get the coordinates of the turning point. You know, when you convert this form to this form, then you can read, right, the coordinates of the turning point. But this is a long way. If you have this form, the quickest, effective and shortest way, quickest, effective, shortest route to your destination, right? This is like you when you are on your GPS and, like, you know, who is it? Mandy D tells you there, recalculating, turn left. You know, there's that long route that freaking you know, GPS takes you on, man, and you're like, I mean, come on, couldn't this thing just take me and move me using the displacement, the shortest route? So here, these guys, this way, the quickest effective way, this, all right, non-leshozi, just use the formula x is equal to. Now, there's a minus sign in this formula. There's a b in the numerator. There's a 2 in the denominator multiplied by a. Where does the b come from? It comes from the coefficient of x. All right. Where does the a come from? It comes from the coefficient of a. All right. It would be nice if we could make a video we could save from the start of this topic. I hear what you're saying. I hear what you're saying. That's a good idea. And trust me, I'll be incorporating it in the future. But for now, I'm just flowing with this, okay? But thank you so much for your recommendations. I always appreciate recommendations shared in the comment section. I may use some of them. I may not use some of them. Say, we're too fast on this one. Sefundo, I don't believe you. I don't believe we are too fast. You know, where have I lost you? Where have I lost you? Because you are saying we are too fast. Yeah, well, being too fast is a very serious thing. Because what's the point? All right. Because remember, if you don't know this at all, then the being too fast will come because maybe you don't know anything at all. If that is the case, I don't have a problem. I don't have a problem going back and explaining again. But remember, I'm expecting that at least there is some knowledge that you do possess. Okay. X is equal to minus b over 2a. So what I'm saying is that if the function, you are given the function in this form, instead of completing the square and then expecting to read the coordinates, this is a long way to the coordinates. Let us rather, when we are given the equation in this form, go straight to using the formula. There is a formula that works to get the x coordinate of the turning point. Turning point x, what do? You say x is equal to minus b over 2a. And now I'm saying to you, the b, where are you going to get b from? It's the coefficient, the number that comes before x. Where are you going to get the a from? In the standard form, the coefficient of x squared is the a value. So you substitute that b and a from your quadratic function. Okay, and then you simplify. You will get a specific x value. Once you get that x value, all right, you will take it and go and substitute it where? There in the equation. Take x, substitute into function, and by that we mean the original function. You come and substitute that x value here and there. Obviously, when you substitute, you use what? Brackets. You don't substitute nje. You use some brackets to substitute that specific value in the place of x. Then doing that substitution gives you the corresponding y value that tags along with this x value that you basically had gotten for the turning point. Okay. Nontle shows you have a question mark. What is the question mark for, my dear? Okay, remember f of x means y, and y is here, so you take the x value, you come and substitute it in the place of x in the function. F of x means y. All right, y means f of x. This here is what we call functional notation. Okay, f of x is just functional notation. That means what? All of it means y. Okay, so the minute you substitute a specific x value in the place of x, then it means you are getting the value of y. You are getting the value of y, all right, for this particular function. So you must first get the x coordinate using this formula, take the x value after you've gotten it, substitute it back into the function, and then you will get the corresponding y value. Yes. Bondle, when you have different functions, let's say you have a straight line that's a parabola, let's say that's x squared plus 3x plus 2. Then you have a straight line that is x plus 1. Then you have a hyperbola that is 3 over x minus 1 plus 2. The reason you will find there being different letters accompanying the bracket x, these all mean y. Remember, generally speaking, this is y is equal to x squared plus 3x plus 2. This is y is equal to x plus 1. This is y is equal to 3 over x minus 1 plus 2. All of them mean y. Okay, Bondle? But we put the functional notation so that you can actually see that I am trying to distinguish the parabola from the straight line from the hyperbola. So we use functional notation so that we can attribute the notation that is functional to denote the different functions, just to show they are not the same functions. That's all. P of x, m of x, t of x, l of x, n of x, 26 letters of the alphabet that you could write here of x. But like I said, what is this? It is called functional notation. Come back, guys. Candidates must be able to use and interpret what? Functional notation. So all of this is called what? Functional notation. All right? Breakthrough, guys. Okay, so if we come back now, would you be able to calculate the coordinates of the turning point if I gave you a function of the parabola that is in this form? I hope you can. Would you be able to determine the determine the coordinates of the turning point if I gave you the parabola in this form? Do you still remember the formula? Do you know what you have to do with the formula? Do you know which coordinate you get when you use that specific formula, x is equal to minus b over 2a? Do you know what you do once you get the x value? Do you know where to substitute it back to get the corresponding y value? I hope you do. I hope you do. All right? I hope you do. So yeah, that is calculating the coordinates of the turning point. Which functions do we use the x is equal to minus b over 2a? We use the x is equal to minus b over 2a when we are given the function in quadratic standard form. Okay, remember that when your function is in the intercept form, this form you can actually multiply out. You can multiply out and get this function to be in this form. Then you go ahead, after getting the function in this form, you use this formula as well. So the formula, you can see where x is equal to minus b over 2a is being used to get the x coordinate of the turning point. It is used in the quadratic standard form of your parabola. Also remember that this form you can distribute, multiply out, and get your equation to be in quadratic standard form. Then you go ahead and use this formula, x is equal to minus b over 2a, to get the x coordinate of the turning point, and then take the x value, substitute it back into the original function, and get the y value of the turning point. Okay. A, I hope we are together. All right. A, I hope we're good. Yeah. Right. No, that's beautiful. I am happy that we are flowing together. Okay. So far, determining the coordinates of the intercepts with the axes, not a problem. Determining the equations of the asymptotes, we understand. Determining the equations of the axis of symmetry, we understand which functions this applies to, and we know, okay, sort of like have an idea, all right, but we are going to look at the specifics of how. Next, calculate the coordinates of the turning point. We know that this doesn't apply to all functions, but it only applies in this particular instance to the parabola. And we know the forms that our parabola can be represented in, and we know how we go about finding the coordinates of the turning point. Then this guy, how to sketch the graphs. Big one. How to sketch the graphs. Do we know how to sketch graphs for all 4 functions? Meaning, do we know how to sketch directly from a given specific function? Let alone that sometimes, guys, these people nowadays are not just asking us to sketch functions from this. Sometimes these guys are asking us to sketch functions by when they give us details. They will give you details in bullet point form, and then they'll be like, sketch the function from the details that you've received. And then when you have to use those details to sketch the function. All right. So first and foremost, though, do we know how to sketch each and every function? A is like, I never understood how to sketch the exponential. A, you're killing me. All right. So I think what's going to happen today is that I am going to actually possibly stop here, because I'm going to spend some time now and look at some functions so that we can better understand how to sketch them. And as I go towards sketching those functions, you are going to see me go through these steps. so that you guys can see the direct application of these things here. All right, I will also, okay, I will leave this for today. Also incorporate that in my explanation, how to write down the domain in the range of a function. All right, also we are going to look at this point, the intervals on which a function is increasing and decreasing. We are going to look at that because as part of our sketch we are going to look at that as well. I'm also going to leave that for today. So these 1, 2, 3, these are the only bullet points I am not going to focus on today because I don't want us to be too much overwhelmed with information. I think we can actually take the bite-sized slice that we are getting for today and we can make use of it. So this, that, and obviously we're gonna leave those 2 for now. That includes also determining the equation of any other function, not just the inverse. Okay, we are going to look at next time, and determining the equation of other functions. Show that a point lies on the graph, we are going to look at next time. Then domain, we are going to look at intervals on which a function increases and decreasing. That's also fine. We are going to look at, we are going to determine the average gradient. Okay, what does when does the live normally start, guys? I'm actually starting at 9 nowadays. All right, 9 p.m. and I pull it all the way to 12. Okay, so it's 9 to 12. Okay, I'm really trying to be consistent in that, having these live lessons every evening, but I will do you the courtesy, if I don't go live, of actually making sure that I, send you a message. I'll actually post on either my stories or something to say that I will not be able to go live today or something like that. But for now, I think I've been quite consistent, either 9. If I don't come up at 9, guys, latest will be 10. Okay, so just bear with me. But if you miss, please then go to my YouTube channel. Link is in the bio. The YouTube channel is also called Maths is a Game. You can always go and rewatch whatever I miss. Okay, who's most kids? You can't be sleeping that early while you're in grade 11 or 12. Not Leshozi, thank you for saying that. Yeah, joy comes in the morning. What precedes that joy is a lot of discomfort, pain, and sacrifice. So yeah, guys, if your child is not going the extra mile, and then I will do that. The person who's been repeating, please do create videos. I'll do that. All right, TikTok short videos. I know you guys love short things. Yeah, I'll definitely do that. Bugetto doll, is it Bugetto doll who's saying that? Bugetto. I will do that. Okay, now let me allow me. All right, let me allow me. If you can allow me, let me allow me. If you can allow me, there's something I wanna do very quickly. I want to look at the individual functions and sketching them. Let's see if you guys will tag along on the journey with me. So we first said linear. So let's look at linear first. Let's say we were given a function y is equal to 2x plus 1. We also understand that when they say y is equal to 2x plus 1, this function could have been stated as f of x is equal to 2x plus 1. We know that f of x is functional notation. So this is still what kind of function? It is a straight line function. Why do we say it's a straight line or linear function? Because we can see the form y is equal to ax plus 2. What do we do when they decide to actually give us the function? Let's say they give you the function like this, f of x minus 2x minus 1, and you look at this and you're like, hi bo, never in my life have I ever seen something like this. Remember guys, at the end of the day, what does f of x mean? we now know what f of x stands for. It stands for y. This is f of x minus 2x minus 1 is equal to 0. So let us just accept then that the form is very important. Me and you need to know very well that any linear function must be represented in this form. We're gonna say these are our standard forms for each function. So your linear function, the anticipated and expected standard form for a linear function is that you're expecting a y that is isolated, but that y can be expressed in functional notation as well. So just expect that as well. But on the other side, you are expecting your x term first, all right? And your x term, if it has a coefficient, that coefficient can be a negative number or it can be a positive number. It doesn't matter. The q value, all right, can be a positive number or a negative number. Doesn't matter. Okay, so if you look at this, your first thing that comes to your mind, you're like, Aibo, this function is not in the standard form. So your first thing you need to do before you even sketch it is first represent your function in the form that you know it's supposed to be in. Take the negative 2x, you transpose it to the other side, the negative 2x becomes 2x. Take the negative 1, you transpose it over to the other side, it becomes positive 1. Now that you are here, check guys what my next step is. So standard form is very important when you are sketching. Okay, that's why I'm writing SF. SF means standard form. 2, know your parameters. Hey, now we are talking stuff. Parameters, your variables of change. Parameters, what do we call those? Parameters are our variables of transformation, the variables of change. There's the parameter A, it has a meaning for your straight line. There's the parameter U, it has a meaning for your straight line. Okay, do we know guys what A stands for? What does the A actually mean for our straight line function? I'm going to allow you guys to comment in the comment section. Allow me to pause the Okay, I had asked a question. Very good. Sfundo kamlenze mncube. Look at you, guy. Look at you. Beautiful. A, guys, means gradient. Okay. A means gradient. So if you look at A, it is the coefficient of x. The what? The coefficient. So the coefficient of x here, right? The gradient A is equal to 2, right? That means the gradient is positive. And let me tell you this, when the gradient is positive, it helps you establish what the shape of your function will be like. Because this is a linear function, a straight line, when the gradient is positive, that means we are going to have an increasing straight line. Okay, it is steeping upwards. It's steeping upwards. It's increasing. The straight line is an increasing function. Okay, it steeps up. It's increasing. In other words, as your x values increase, the y values also increase. All right, that is when A is positive for a what? For a linear function. Please guys, Please, guys, don't ever miss that. Now, because we've spoken about A for one scenario, and that will be the scenario that we're going to be sketching, I want you to now take note of the other possible scenarios, and I want you to establish or tell me in the comment section. All right, if the equation was y is equal to negative 2x plus 3, what would be the value of A? Talk to me in the comment section. Okay, and please, when you do this, please always make sure that y has a positive coefficient, and that coefficient is 1, because you cannot state the true gradient. You cannot state true gradient until your equation is in standard form. Your equation, your function must be in standard form. Your function cannot have gradient stated unless it is in standard form. Do you see, guys, that? I hope you understand this, because for instance, if I was given this straight line function in this form, I can't just state the gradient and say, no, the gradient here is negative 2. And then I ask you why, and then you say, no sir, it's because the coefficient of x here is negative 2. No, guy. First, get the equation into standard form. That's why I've endorsed that as step 1, that your function that you have must first be in standard form. Then you can make a judgment on the parameters. In other words, your A and your Q. So your A value, we said, is the gradient. If A is positive, we understand we have an increasing, steeping upward straight line. Now you are saying here A is equal to negative 2, right? And we can say that comfortably because this equation is in standard form, all right? What type of straight line is our function when A is negative 2? We can expect a line, since A is less than 0, we expect a decreasing straight line. So this function is steeping downwards. So we steep downwards, or slope. Okay, steep or slope. Steep or slope. You might find that these words are used synonymously. Sloping downwards. All right. Okay, sloping downwards. So this means as x increases, y is decreasing. Wonder boy, Grado, you are hilarious, that's for sure. What is this, man? All right, steeping downwards. I think Wild Wonder Boy is sleeping downwards and is yawning downwards as well. Yeah, it's like bored, like nobody's business, thinking this is geography. Hilarious boy, that one. Okay, when A is negative, A is less than 0, sleeping, it's steeping. You see, now I'm saying sleeping, it's steeping downwards. Decreasing function, this one. Okay, as x increases, so from left to right, x is increasing, but y, what's happening to y? It's decreasing, it's going down. Okay, that's when A is negative. There's other prevailing scenarios which I want to quickly look at, and that is when y is equal to, let's say y is equal to 3. Okay, so that means that here, do we have this ax part? No, we don't. So if we don't have this ax part and there's only the q value, that's why we're saying y is equal to 3. Then what does that mean about a? It means a is equal to 0. What do we know when a is equal to 0? Our line will be horizontal. Horizontal, brother. Horizontal. When your gradient is equal to 0, how do you know your gradient is equal to 0? You will see that the standard form is still upheld. Y, there's a y. Equal, but then there's a constant term, meaning there's a q value only. Where is the ax? You ask yourself the question. There is nothing with a and x, which means the a value is 0, because 0 multiplied by something else only leaves you with the q alone. So that means when a, our gradient, is 0, our line is a horizontal one. Then there's the last scenario, when a is undefined. Guys, when a is undefined, then that's when you have the equation, very unfamiliar to all equations that you get. This one is still y is equal to something when a is positive. This one is still y is equal to something when a is negative. Okay, there's the shape decreasing. This one is still y is equal to some constant value, but you notice that the line is horizontal. But this one, when a is undefined, which happens, guys, that sometimes the gradient is undefined. Gradient is undefined. Then you will have an equation, x is equal to some constant value. And when x is equal to some constant value, the shape of the function is a vertical line. No, you cannot define it, my guy. You cannot define it. Kaloku, the gradient is undefined. Okay? You just say the gradient is undefined. You cannot define something that is undefined. You simply say it's undefined. It's as simple as that. Okay? It's like dividing by 0. Can you define division by 0? Like if you say 5 divided by 0, can you define that? No. You say 5 divided by 0 is undefined. The lost, Mokhwandi is saying the lost y is equal to 3. Y is equal to 3. Mokhwandi, y is equal to, let's say, ax plus q. If your a is 0, what happens to x? 0 times x, what is 0 times anything? You multiply 0 with anything. Guys, you multiply 0 with anything. What happens? Okay? It becomes 0. Okay? Yeah. Now I am saying to you, but you have your u value. So that is y is equal to 0 plus 3, therefore y is equal to 3. When you have y is equal to only a constant, meaning only the u value, what does that tell you about the gradient? It means that the gradient, we don't have it. It is nothing. In other words, it is 0. If the gradient is 0, I'm saying to you guys, then you will see the shape of your straight line function will not be increasing, it will not be decreasing, but it will be horizontal. A gradient that is 0 is represented by a straight line that is horizontal. Your ruler, guys, you see, I've just free-handed this, but your ruler, a horizontal straight line. Okay, then moving right along. Now I'm saying when a is undefined, as it does happen sometimes, that if you're wanting to calculate the gradient and your x values are the same everywhere, your x values are the same everywhere, then obviously the equation of this vertical line will depart from the usual equation. It won't be y is equal to something like when your gradient is positive. It won't be y is equal to something like when your gradient is negative. It won't be y is equal to some constant like when the gradient is 0 and the line is horizontal, but it will be x is equal to something. So for instance, if I say x is equal to 5, this is a typical equation of a straight line that is what? Vertical. And it has the equation x is equal to whatever the constant x value is along that vertical line. And this is unique for when the gradient is undefined. We say x is equal to a particular constant value. That's unique to a vertical line. We say x is equal to a particular constant value. And the line is vertical because your gradient is undefined. Okay? I hope we are together here. Right? So this was all unpacking shape, which is step 2. All right. Remember, at the end of the day, I was just focusing on this f of x is equal to 2x plus 1. But I had to explain all the other options so that you can be aware and equipped with the knowledge to know, okay, so if a is negative, then it's a different shape. Or if a is 0, then it's a different shape, it's horizontal. Or if we are told that the gradient is undefined, then there's no doubt in our minds that this type of graph will be a vertical line, a vertical straight line. Okay? Now, step 3. After establishing shape in your head, you are like, okay, so when I sketch, what am I expecting? I'm expecting a increasing straight line. You begin with the end in mind. You begin with the end in mind. There is no powerful motivator in life than to start having a clear vision as to what you want to see at the end. That helps you to then put a plan in place because you have a vision of what you intend to achieve. That objective that you intend to achieve then needs to be accompanied by a plan, a step-by-step plan towards achieving that objective, which I can clearly see. So what is the plan after having established what the a value is and understanding that I should then, when I sketch, have a increasing line? The plan is the following. Step number 3, we are now going to find the x-intercept and the y-intercept. Now this is your daily bread. This is your stuff. When I say x and y intercept, do you still remember what we said is the x and y intercept? How do we get it? And hopefully you guys can see that those were the things that were stipulated earlier on that you need to know. You need to know how to find the coordinates of the x-intercept. So Wild Wonder Boy, I see Wild Wonder Boy has come down, left the geography, and now is settled down. Incy Spider, climbing up the spout, now wants to answer the question, x-intercept. So for x-intercept, we are going to let y be equal to 0. So we go grab our function. There it is. Okay. In the place of y, we are going to substitute who? 0. In the place of f of x. So the entire f of x, we say 0 is equal to 2x plus 1. Okay. But I think for order and for convenience, rather have the expression 2x plus 1 on the left and then have the 0 on the other side. So I would literally start it off this way. 2x plus 1 is equal to 0. Because remember, 2x plus 1 plus 0 is equal to 0 is the same thing as 0 is equal to 2x plus 1. It's one and the same thing. Then when we solve, like Wonder Boy is getting ahead of us in the comment section, we transpose the 1, it becomes negative 1. Very good, Wonder Boy. At least your second attempt reflects the true answer. Then the coefficient of x is 2, so we divide both sides by the coefficient of x because 2 and x have a multiplication relationship. We want to get rid of 2 that is multiplied, so what do? The inverse, we divide by 2. But what we do on the left, we do where? On the right. We get x is equal to a negative half. Langa, you are saying start over. You see, when you say start over, you must be specific about where do you want to start over. Because if you are saying I must start over from the very beginning, as in like from the beginning of the lesson, that is not going to happen. Well, you, my guy, can actually go and subscribe to my YouTube channel. Go to the link in my bio. Go and click there on the link in my bio. There's a link there, https :// YouTube at Maths is a Game 527. You can click on the link. It will send you to the outsource page, which is on YouTube. Subscribe there, and then when I upload this video later on, we'll be able to get the video, and watch it from the beginning. You are saying we don't care. No, we do care. We care very much. But remember, I care more for those people that have been following me along, because I'll be slowing them down, going back to the beginning, because there's so much we've covered so far. So it's unfair on those that have been here since the onset. Okay, we care very much. PEMS, Forex is the future. Yeah, just make sure you are careful. Right, then after finding the x-intercept, we can then write down the coordinates. Okay, x is equal to -half. We can then say x -half, y is 0. So those are our coordinates. -half. Remember, we let y is equal to 0, so indeed the 0 is reflected there where y is, and then x -half is reflected there. Next step, find the x-intercept. Okay, sorry, y-intercept. When we want to find the y-intercept, we let, yes, very good, we let x be equal to 0. So hopefully you guys are also following along and you are doing the calculations on your own, so that you can see that you can apply the skill. So f of 0, guys, so in the place of x we substitute 0. So f of 0 is equal to 2 times 0. Please make sure this is the expression. It's 2 times 0 plus 1. 2 times 0 plus 1. Ne? Yeah, then 2 times 0 is 0. 0 plus 1 is 1. So f of 0 is 1. Therefore, our x coordinate, we let x be 0. So that's x is 0, corresponding y value is 1. So we have 0 and 1. There we go. X-intercept, check. Y-intercept, check. Okay, so far I would say we are good. All right, now, do we have everything that we needed to sketch this? I would say yes, because what have we just used? We have just used a method that we call the dual intercept method. Okay, the dual intercept method. Dual means 2. So we found our 2 intercepts, the x-intercept and the y-intercept, and that's sufficient to then go ahead and sketch our graph. So now it's a matter of using the coordinates and going and sketching our graph. So what I'm going to do is I'm going to sketch, just going to draw a Cartesian plane here. All right, already in my head I can see the shape. I'm not expecting the shape to be anything else but this, because if it's not, then it would actually be going against the idea that a is 2, and therefore the a being 2, it means a is greater than 0. We're expecting an increasing function. So let's go and locate -half and 0. X of -half. So let's just put here we have -1. Let's put here we have 1. And then let's say it's 2, -2, just for control. So x is equal to -half. The -half would be in between 0 and -1, midway. That is -half. It's this point. The -half and 0. Remember, this is the x-intercept, so this is where the function will cut what axis? The x-axis. So we are exactly here. -half and 0 are exactly there. What is the other point? 0 and 1. 0 is for x, 1 is for y. So on the y-axis, we are going to locate 1. Where is 1? So let's just say that's 1, 2. So 1, okay, for y, x is 0. Remember, x is 0 is everywhere on the y-axis. So these are our 2 points. 0 and 1, this is -half and 0. 0 and 1, -half and 0. All you do is you take your ruler, you place it with these two lines. And please guys, I'm going to freehand, but you would use a ruler. You sketch, okay, and then you just draw arrows on the end to show that the function is infinite in this direction and in that direction. And then you can label the graph. F of x is equal to 2x plus 1. Then you will get the marks that you deserve. 1 mark for x intercept, negative half. They need to see that. 1 mark for y-intercept, and usually sometimes the 3rd mark for the shape, because remember what we were expecting, an increasing line. Did we get one? Yes, we did. So that means we located the exact coordinates that we need, and those are 100% correct. And dang, I'm happy. Oh, I'm happy. Oh, I'm happy. Okay, straight line does not have no turning point. Straight line does not have no axis of symmetry. Straight line does not have no asymptotes. Okay, yeah. So guys, all right, I see someone saying write the coordinates on the Cartesian plane. Now the thing is, if this 1 is clearly spelled out and they can see my dot there for that point, then that's fine, that's enough. Okay, they understand, all right? And if they can see the negative half and then I have shaded the dot there, then that's fine as well. I don't need to necessarily write the coordinates for the intercepts, okay? But if you really feel like, yo, I was taught otherwise, then go ahead, my dear, please. Do not allow yourself to basically be sabotaged. Go ahead, write down the coordinates, and I guess that makes your function for you complete. You don't lose marks if it is clear that for 0 and 1 you have placed the 1, which is the y-intercept, for the y-axis, and for negative half and 0 you have put the point and you have actually indicated the negative half. That's fine. You would not lose the marks. Okay, and some of you are probably like, hi, but sir, what's the point, Moss? You must write the coordinates. Well, okay, if you want to write the coordinates, please don't allow me to basically shift or turn your mind around. You can write the coordinates, but I'm saying you will not be penalized if you don't write down the coordinates, as long as it is distinctly clear that you've marked the point for the y-intercept. The 1 is there to indicate that, okay, on this y-axis, where we know x is equal to 0, the y-intercept is 1. On this x-axis, where the x value is negative half, and the x-axis, the equation of the x-axis is y is equal to 0, then we know that that is the x-intercept. Okay, but if you really feel like I'd rather be safe than sorry, then go ahead, be safe, my dear. Especially if it's something that is second nature for you. Write down the coordinates 0 and 1, negative half and 0, and then please label the function to show that that is the function f of x. Okay, so for a straight line, it's quite straightforward. Okay, yeah, it's quite straightforward. And something else that you should note, guys, is that if you look at this constant, all right, and this is something I wanted to emphasize as well, that in as much as a is the gradient, your q value here is what we call the y-intercept. It is the value of the y-intercept. So look at q, for instance, here. Isn't it positive 1? Yes, it is. Isn't where the graph cuts the y-axis, isn't it cutting at 1? Yes, it's no coincidence, guys, that this and that agree. So if you have your equation in standard form, your gradient will be clearly noticeable to you. The shape is basically going to be informed. The q value will be noticeably clear for you, and you will know exactly, without even finding or solving the y-intercept, you'll know that, oh, the graph is going to cut the y-axis at 1. Okay, graph is going to cut the y-axis at 1. Okay, so that's what's beautiful, guys, about knowing our parameters. A, right, speaks to gradient. Q speaks to the y-intercept, where the graph cuts the y-axis. Where on the y-axis will the function cut the y-axis? It will cut it at 1 because the Q value is 1. Okay, guys, I think that explanation was suitable and it was beautiful, and I am happy. Now I want to answer some questions that basically pertain to the following things: domain and range. What? Domain and range of the function. In the comment section, what is domain? Domain is the possible x values where Mr. Function exists. All right, and we look at domain, guys, from left to right. Where now when you look at domain, you must look at it from the left to the right, everything you own in the box to the left, yeah. You know what I mean? Possible x values where the function exists from the left to the left, from the left to the right. That's domain. Possible x values where the function exists from left to right. So let's look at that first. We'll look at range. Very good. And Nontleshe, thank you so much. In the comment section, Nontleshe is saying range is the possible y values where the graph exists. Can you tell me, orientation wise, from where to where, Nontle? I want to ask you that, just so that we can beef up that definition. Range is the possible x value, y values. Range is the possible y values where the graph exists. From where to where? Domain, you said from the left to the right. What about a range? From where to where? That's what I want Nontle to tell me. Nontle, I'm saying from where to where. You see, I'm very deliberate here. From left. Look at left. Where is left? Left is domain, guys, is from left to right. So why am I saying from left? Because on the left we have your smallest, guys. Don't play around here. Smallest value to big. Okay, all right, we are being very deliberate that domain, you want to check where the function exists, but you want to check it from left to right. So it's from the negative to the positive, from smallest value to big value. So if we are talking about range, we know we are not talking about x now. Now we are talking about the possible y values where the function exists. But my question to you that I'm asking is from where to where? Where the function exists. I need you to tell me about direction, guys. You see, domain, I said left to right. Now in your head it's instilled, okay, domain, we look at it from the left to the right. Because why left? That's where we are small. Why to the right? That's where we are big. Mohwandi, thank you so much. Is it Mohwandi? Am I saying it right? Okanye Mugwandi? Yeah. From the bottom to top. Thank you so much. You guys, down, up. Yes, down, up. Why? Because we are always taking from small to big. Small to big. You must never write your domain big to small. You must never write your range big to small. No. It's always from smallest number to big. It's from your smallest to your biggest. The orientation of writing down your range and domain is never from big. You don't ever start from big. You start from small. So domain, possible x values where the function exists from left to right. This is small to big. Range, possible y values where your function exists from the bottom to the top. You see? Yeah, we're talking. So if we come here, I want to ask you now. Now I want us to get down to the nitty-gritties, the actual. I want to write down my domain for this straight line. And my question then is to you, what is the domain of this straight line? What would be the answer? If you typed above, right, type afresh. I need the answers. What would be our domain for this straight line function? Domain? Okay, Wild Wonder Boy is saying negative half to infinity. Okay, and the Wild Wonder Boy is saying this because I guess Wild Wonder Boy is looking at this negative half and is seeing that the function is existing at this x value. But then it seems like Wonder Boy is saying the function continues to exist after infinity. Negative half to infinity. Not like saying negative half to infinity because we don't know where it stops. Okay, I hear you, ne? I hear both of you. Negative half greater than infinity. Wonder Boy is saying, not like saying negative half to infinity. Now guys, I want to shock you. I want to ask, is there a place from left to right where this function won't exist? Let me ask you this question. Is the function existing here? Is this still the function, this place? Is this still the function? Just yes or no in the comment section. Is this the function still? Just from here, the dot going on. And what about this arrow? Okay, Wild Wonder Boy is saying yes. Very good. I hope all of you are saying yes. The function is existing here. Okay, can anyone tell me what the x value is when I get here? Okay, so you'd have to go up and check. Oh, it's -1. So the x value here is -1. And it seems like this function continues, right? It continues on. The arrow indicates continuity. So this function is going to be infinitely represented coming from the negative, the most negative direction. So is there an end in the negative direction? If we look at the fact that there's this arrow and it's going on forever, is there an end in this negative direction? That's what I'm asking you guys. Is there an end in this negative direction when it comes to this function? Is there an end? Are there limits? Is there somewhere where it's going to stop? Okay, Wild Wonder Boy is saying no. Guys, he's saying no. Guys, I hope you are all saying no. There is no limit, all right? No limit. So that means this function, negative infinity, from negative infinity, it's going. But look now, it's entering the positive region as it comes to this zone above, you see? And therefore, the corresponding x values are positive. So from negative infinity, is this function going to end somewhere in this positive direction? Okay, is there anywhere where this function does not exist, guys? Can someone tell me and say, yes, at this x value, there's a specific x value where this function is not going to exist? What I want to know is where. Or is this function going to exist everywhere? That's what you need to explain to me. Is there a place where this function does not exist? That's how, guys, you read into domain. Thank you, Wild Wonder Boy. The function will exist everywhere. For every possible x value that you can imagine, from left to right, the function is going to exist. There is nowhere where the function is not going to exist. So how do you then write that down as your domain? How do you write that down mathematically? Nontle shows it says from minus to positive infinity. So yes, guys, please, you say x is an element of negative infinity to, the semicolon means to infinity, which is positive. This is a way in which you can represent your domain for this particular straight line function, where there are no what? There are no limits, because the arrows both indicate the infinite nature in the negative direction and the positive direction that these functions basically exist. Okay. Or you could shorten it and say x is an element of R. The way I like looking at this element of R is like MTN, everywhere. The ER, everywhere you go. So when we say x is an element of R, understand that it's just another way of writing this very same answer. Every real number of x that you can imagine, the function will exist. I repeat, everywhere, every real number, from left to right, from left to right, the function will exist. Every real number of x from left to right, the function will exist. That's what it means. Element of real numbers to me speaks everywhere. It's like long form of everywhere. Okay. Are we good, guys? The domain. Are we domaining? I hope we are domaining. Next, what about the range for this particular function? This one. Okay. So once again, domain, our definition informs how we answer. We are domaining indeed. Beautiful. What about range? What is range? Yes, Wild Wonder Boy. Okay. Wild Wonder Boy is also ranging, it seems. Not only domaining, not only dominating. Guys, domain, when functions must be your domain. It's where your marks must be possible. It's where 100% needs to be possible. Okay? That's where 100% needs to be possible. When you are doing functions, guys, you must say 100% is possible. Just like, possible y values and x values. It must be your domain. Range, we said it's the possible y values where the function exists from the bottom to the top. From the what? From the bottom to the top. Okay, so now you are looking at the function, right? And when you are looking at it, you are looking at the corresponding y values, looking at it from the bottom to the top. This will continue to go down forever. This will continue to go up forever. So that means what for y, guys? What does that mean for y? Yes, Nontle, thank you so much. Nontle and Wild Wonder Boy, you've got it right. Your range this time round will also be y is a element of negative infinity to positive infinity. This is one way of writing the answer. Or you could say everywhere we go, there's all the y values you can imagine, the function will exist. Y is an element of R. Okay, guys, I think me and you, we are in the same page. All right. Yeah, I think we are definitely in the same page. Okay. Right. Okay. I'm going to look at another sketch of another function. We're arranging, yeah? Very good, Nonhla, very good. I'm very happy. Let's look now at Mr. Parabola. Okay. Diapela, guys. Oh, shame. Yeah, guys, I'm gonna be ending the live at 12. Okay, so whatever I stop, okay, wherever I stop at 12 o'clock, which means you guys can watch. You'll go and watch. Okay. Washing dishes and watching your stream is unbelievable, is it? You right now, you're washing dishes at 10 to 12. Yes, I'll continue tomorrow, guys. Scotch, I'll be continuing tomorrow. Okay, so we'll convene again tomorrow. I will pick things up exactly where I left off, and I will be saving this video and uploading it in my YouTube channel. Link is in my bio. You can go watch it in your own time. Just if you missed something, or maybe you were sleepy at some point, you were shonering, like Gazi is saying, I'm pellaring. My pillars are everywhere in the house. Just make sure that you join me tomorrow at 9. Yes, 9 p.m. It's a diet, guys. It's a diet. Are you ready to go on a diet? Wanna go on a diet? Yeah, 9 o'clock, people, 9 o'clock. Okay, parabola. Let's not get too excited. Yeah, it's a date. Wanna go on a date with me? You wanna date me? I'm just kidding, man. Okay, y is equal to x squared plus 3x plus 2. So let's just look at this function. Okay, what type of function is it? It's a parabola. Okay, let's unpack step by step. It seems like this one is in the form of ax squared plus bx plus c. Okay, and then we are going to compare this one with this one. Okay, let's come here. We are going to do both of these. So allow me to do all of these now, and then yeah, I will stop after I've done and sketched these, and then we'll continue with the others tomorrow. Okay. But yeah, it would be nice if you guys could also maybe go to textbooks or find some questions on sketching and just check if you can sketch a straight line and see if you can sketch a parabola. I don't have specific exercises for that, unfortunately, but like I said, as I progress and as I finish, then we'll be looking at like specific exercise, exam type questions and all of that stuff. But it's important to first understand the concept, which is why I'm doing this piece by piece, line by line, slowly by slowly. Y is equal to x squared plus 3x plus 2. Yeah, it's the quadratic form, right? Our a value, we start there. Step 1 is equal to 1. What does that mean? When a, the coefficient of x squared, is positive 1. Okay, so first things first, we can see equation. Is it in standard form? Yes. If it wasn't, it would be our mission to first get the equation into standard form. We can't tell what a, b, and c are until the equation is in standard form. And I said the standard form of this equation is y is equal to ax squared plus bx plus c, where y has a coefficient of 1 and it's positive. You can't have y having something else. If it does, then it becomes our priority to divide by that thing and get rid of it so that we have a positive y with a 1 coefficient. Then we can say the equation is really in standard form. Okay, so the true standard form of a parabola is when y is isolated and it's positive 1, that's a coefficient, and then basically the standard form of the quadratic form is observed. Then we can come and say, what is the value of the coefficient? Meaning, what is the coefficient of x squared specifically? The value of the coefficient of x squared, it is 1. What do we know about 1? It's greater than 0. Since it's a parabola, remember, parabola is not a straight line. A parabola as a quadratic function can either be represented, so when a is greater than 0, what do we do? When we are positive, we smile. When we are positive, we smile. When we are positive, we smile. Smile and smile and smile and smile. Yeah, in other words, concave up, buddy. Concave up. When you're positive, a is greater than 0 party, you smile, hey, concave up. Okay, so that's the first thing. So we begin again with the end in mind. In our minds, we already know that when we sketch this function, we're expecting a smiley face, nothing else than that. 2, turning point. We first get the turning point. Guys, when the equation is standard form, do you still remember what we do to get the turning point? Turning point is the next thing after A, guys. Immediately after A, don't waste time. Get the turning point. Get where the function turns, please. You know? Thank you, Nontle. Guys, be careful. We don't want B over 2A. It's not positive B over 2A. It's negative B over 2A. And what's even beautiful is that, who's this? Alicia even like solidifies it by writing the entire equation in the way that it's supposed to be written. You know, x is equal to, we don't say minus b over 2a, we say x is equal to minus b over 2a to get the x value, the x coordinate of the turning point. Let's go ahead and substitute. We say negative. The b, what is the b value? Come on, guys. I'm just going to unpack these things for us. Then sub your x values back into the equation to get the y value. Very good, Nontle. Our b is 3, so we substitute that over 2 into a. A is 1. Then we have what? A negative 3 over 2. That's that. That is the x value. So in my head, I know this is negative 1,5. It's always good to have the decimal in our heads, because sometimes 3 over 2 for some people won't make sense for them when it comes to the Cartesian plane and when they have to actually identify where negative 3 over 2 is. So in my head, I'm like, okay, calculator quickly, negative 3 over 2 equal to SD, so that I can get the decimal value. Don't write down the decimal value, leave the fraction form, but have a knowledge of where that x value is situated on the Cartesian plane. All right, then you take the corresponding, that x value, you substitute in the place of x so that you can get the corresponding y value. So negative 3 over 2 squared, you get 9 over 4 plus. Okay, so here we don't have an exponent, so we can multiply positive times a negative. That gives us a negative. Then 3 times negative 3 over 2. Guys, please, very importantly, because sometimes I see people doing funny things. 3 times negative 3 over 2 is negative 9 over 4. You multiply the 3, which is in the numerator, with the negative 3 in the numerator, you get negative 9. It's not over 4. It's 2, sorry, negative 9 over 2 plus 2. Okay, yeah. Then you can put this in your calculator to get the actual answer. 9 over 4 minus 9 over 2 plus 2, because you don't have to, it's not necessary to actually do the whole LCD, try and get the specific. You can just grab your calculator, put all of this in. I can see our good friends have already gotten us the answer of y, which is y is equal to negative 1 over 4. Turning point, I'm good. Negative 3 over 2, negative 1 over 4. But also additionally, remember, this negative 1 over 4 calculator gives me 0.25. So I know this is also negative 0.25. Just to have an awareness that in my calculator, in my Cartesian plane, where is that value? Tom Miley, definitely, buddy. Yeah, that's at night, at midnight. Tell me about it. Tom Miley, before you leave, can't you just pump in there some ice cream and some roses, just for the midnight ice cream snack, if you want to call it that, or what is it? Good smelling roses, if you want, or whatever it is, man. Yeah. Oh, you awesomes, man. There's some you awesomes, guys. My life goal there. Life goal. I have you awesomes as part of my gift gallery goals. I know that galaxies and money guns may be a bit too far-fetched for some of you, but yeah, I love the cats, the you awesome cats. Love those. If you can send those, I'd really appreciate it. So yeah, we leave the turning point in that fraction form. That's fine, but we just have the decimals in our heads, don't necessarily, so that we can know where to represent them on the Cartesian plane when we do sketch. So just keep the fractions. It's the way we go. Number 3. Now, since we have that, it's now time to find the x and the y-intercept, the two twins, the dual twins. X-intercept, we know we let y be equal to 0. Y-intercept, we know we let x be equal to 0. So let's go. Let y be equal to 0 in this place. So we're going to say x squared plus 3x plus 2 equal to 0. Then we solve. Factorize time, factorize time, factorize time. X plus 2 and x plus 1. 0 factor law. So our solve for x skills should be on, should be like on song. Let x be equal, so our coordinates quickly, -2, obviously with 0 because y is 0, -1 and 0, just so that we have the actual coordinates. There they are. These are our x-intercepts. These are the actual coordinates derived from the x-intercepts. Y-intercept, we let x be equal to 0, so y is equal to 0 squared plus 3 into 0 plus 2. Y is equal to 0 plus 0 plus 2, so y is equal to the 2. Then we say our coordinates are 0 and 2. Okay, very good, guys. Good job to all of you. I know you guys are doing these very well. Thank you very much. Really appreciate you. Really appreciate you, my brothers and sisters. Okay, now, and then after you're finished, yes, it's because they are the best teachers that we have in mathematics, and they are amazing. So that is why I am making sure that I put on my voice so that your guys can also be able to succeed and do very well in your mathematics. Yeah, your mathematics, very important. So x-intercept and y-intercept, there we have it. I want to see something called Wonder Boy. I don't know if we'll be able to get to the exponential today because, yeah, man, I wonder what you are waiting for. I might just do it just for you, but I don't expect people. I'll definitely be doing it anyways tomorrow, the exponential, unless you guys are saying I mean days later. Oh, you mean days later? Okay. Yeah, so we have x-intercept, y-intercept. Now we are ready. What are we ready to do? We are ready to sketch because we have all the details that we need, don't we? Yeah, we do, guys. So let's see the sketch, how it is. Let's see it. All right, let's see it. Let us see it. All right, y-intercept. Y-intercept 0 and 2. X-intercept -1. -1 is here. -2 is there. -3/2. In between -1 and -2, it is -1,5. So it's in between there. -3/2. Just mark it. -1/4. So -1/4. If -1 is here, just for argument's sake, -1 is here, then -1/4 obviously is 0,25. -0,25. Let's say it's here. -1/4. That means where these two meet, -1/4, and -3/2. Where we meet here. We have a part here, -1/4 horizontal, -3/2 vertical, That's where we meet for the roll day. Then the turning point is here, so that means I'm gonna turn here and turn there, right? So let us bring it down here, turn there, and then go there. Okay, with our beautiful pencil. All right, there we turning, then we mark there for 2. All right, then I know some people insist they want to write the coordinates on not on 2, but I mean, like I said, it's fine. If you mark the point, you can just write 2 there. Then -1, it's there, so you can say -1 and 0 if you want, but I mean, it's fine if you write -1. It's 100% fine. -3/2 together with -1/4, these two are fine. -1/4 and -3/2, it's fine. All right, then here -2, 100% fine, 100% fine. You can just write -2. Some people insist that they want to write the coordinates, but guys, I would really say it's fine if you write -1. If you write -1, it's fine, as long as you mark the point. The turning point, you can go ahead and write -3/2 and -1/4, so that one is evident, and then you just make sure the dot is very clear. Then I usually advise learners personally that, hey guys, just for the parabola, the axis of symmetry, use a ruler, you draw in the axis of symmetry. The equation of the axis of symmetry is x is equal to -3/2. It coincides with the x coordinate of the turning point. I insist on the axis of symmetry because it basically helps you to just know. Yeah, but like I said, guys, it's not a real must, but like I definitely do insist on the axis of symmetry being in there. All right, because in the event they ask you for which values of x, they like these questions. They ask you a question like this. They say, for which values of x does the function increase? Let's see if you can answer these for me. Okay, I think I'm gonna stop right here, guys, after answering these questions. Yeah, I'm not even going to sketch this one. I'll allow you guys for homework to sketch this. Tomorrow, when we have the live lesson, we'll continue and pick up from where I left off, and we'll go on and do hyperbola and exponential. So can I save hyperbola and exponential for tomorrow, if that's okay with all of you? I know that I'm not the only live creator, that you guys, if you want to look up things and you can find out things, you can find them out via alternative ways. So I'm not limiting you in any way, all right? But can I just hold it here for today? I don't want to over bombard us with information. I do want to allow you time to digest what we have done for today. And then, yeah, you can find exercises and try and see if you can't sketch all the functions, and to also try to apply some of the things we've learned, okay? Yeah, so you see here for the parabola, I've decided to sketch in the axis of symmetry. And as I said to you, the equation of the axis of symmetry is x is equal to the value of the x coordinate of the turning point, because x will be equal to -3/2 everywhere on this vertical line. All right, so for which values of x does the function increase? Guys, do we know that this function actually decreases here? It's decreasing, it's decreasing, it's decreasing. Question, where does it stop decreasing? As it decreases here, where does it stop decreasing? There. Okay, usually say this is the turning point or the stationary point. Then what happens after this? It increases, it increases, it increases. So now if they say for which value of x is the function decreasing, who are you going to use? Which value of x are you going to be using to be judging that and then writing your answer? So that's where the axis of symmetry plays a big role. This vertical line is going to be sort of like your pillar or your pole of judgment. This negative 3 over 2, you ask, where is the function? What is the function? Where does the function increase? So the function is obviously increasing from here. Which x value is this? It's where x is greater than what? Negative 3 over 2. Why am I saying x greater than negative 3 over 2? Because this is x is equal to negative 3. But when we are greater than negative 3 over 2, look at what happens. The function is increasing. You see? But when we are less than this x coordinate of the turning point, which is the x subsymmetry, when we are less than that, the function is decreasing. So I could answer this question: for which value of x is the function increasing? X greater than negative 3 over 2. For which values of x is the function, well, let's say, decreasing this time around? Where would we say it's decreasing? If it's increasing at x is greater than 3 over 2, which you can see physically, where is the function decreasing? For which values of x is the function decreasing? Thank you, man. When Alicia, for the love of you and Nontle, x is less than negative 3 over 2. For the love of you both. Yes, where x is less than negative 3 over 2, we are decreasing. Where x is greater than negative 3 over 2, we are increasing. And guys, please, if the function is concave down, if the function is like this, then the function is increasing where x is less than the x coordinate of the turning point, but the function is decreasing where x is greater. You see? So would it be difficult to answer such questions? I hope not. Then domain. Let's talk about the domain of this function and the range. Let's start with the domain. Okay, remember, what did we say the domain is? Domain is the possible x values where the function is. Possible x values where the function exists. Possible x values where the function exists. The domain is the possible x values where the function exists from left to right. Now let's go with the function. There's an arrow here. The arrow means yo. So you see, from left to right, from left to right, everywhere, the function is existing everywhere, from left to right. From left to right, the function is existing everywhere, from left to right. You can see that from left to right, the function is existing everywhere, more especially because of the arrows. Okay, everywhere you go. So Siklimba, yes, we can say x is an element if we want. Negative infinity to infinity with open brackets, or we can say x is an element of real numbers. Left, right, cha-cha. Yeah, Alicia. Then what about range, guys? Yes, you can either or. If you write it this way, 100% correct. If you decide to write it this way, 100% correct, because these two things mean the same thing. Then what is the range? Possible y values where the function exists. Where does the function exist? Possible y values where the function exists from the bottom to the top. Bottom. So what are we thinking about when you think about range? Y values. Where is the bottom to the top? Now I'm going to wait for you guys to tell me. Started from the bottom, now he. Started from the bottom, now he. Started from the bottom, now he. Yeah. Started from the bottom, now he. Yeah. Started from the bottom, now he. Started from the bottom, now he. Started from the bottom, now he. You know. Started from the bottom, now he. Started from the bottom, now he. You know. Yeah. So guys, I need more comments there. Need more comments. Wild Wonder Boy, y is an element of negative 1 over 4 greater than infinity. Okay. Now it shows y is an element from negative to positive infinity. Okay. Gazi, y is greater than negative 1 over 4. Okay. Mr. B, Nandi, Gamondi, y is greater than negative 1 over 4. Okay. Okay, so guys, mad love for your attempts. Mad love for your attempts. Mad love for your attempts. Y is an element of negative a quarter less than or equal to infinity. Okay, guys, we need to be careful with the range. It seems like the range for a parabola may just be a bit of a struggle. Remember that this is your minimum value. Y is equal to negative 1 over 4 represents your smallest, lowest value of y that the parabola can reach. So we started from the bottom. Which bottom? There, this bottom. Then where are we? Where are we? Are we somewhere? Or is it limitless? Look, we go up infinitely in both this side and that side. So what does that mean? Yes, Nontle. You see, Nontle, now you are speaking. You are speaking my language. Nontle's the answer, guys. My Shozy. Nontle Shozy. Nontle Shozy. Shozy Nontle. Yeah. Nontle Shozy. Okay. Nontle said y is an element. Square brackets. Negative a quarter. To what? To infinity. Open brackets. Okay. Wild Wonder Boy says you answered a long time ago, but the answer was not correct. Wild Wonder Boy, that's the thing. Okay, we use square brackets, not open brackets, from negative a quarter to infinity if you decide to write your answer in interval notation. That's how you go about it. Or you could write it in equality form. Y is greater than or equal to negative a quarter. You people said y is greater than negative 1 over 4, but you did not include 1 over 4. We also include 1 over 4 because negative 1 over 4, sorry, because that's where the function touches, which is the most basic minimum value of y for the function. So we do say y is greater than, not just greater than, but greater than or equal to negative a quarter. Are we together, guys? Please, let's be careful with not doing the opposite. Y is greater than or equal to negative a quarter. So these are one of two ways to write the answer. Okay? Please, guys, range is the possible y values where the function exists. Writing the answer in any other way is incorrect. So be careful to write the answer either in interval notation or you can express it in inequality form. Okay, why is it positive infinity? Because above the x-axis, remember here below the x-axis our y values are negative, but above the x-axis our y values are how are our y values here? Y values above the x-axis are positive. Since this parabola goes up infinitely, what does that mean? It means that our y value does not reach an actual end. Our y values are limitless. So therefore we say to positive infinity, because this is positive values of these are positive values on the y axis, okay, above the x-axis. So it's up until positive infinity. It can't be negative infinity. As I said, range is the possible, please guys review, range is the possible y values where the function exists from the bottom to the top. Small to big, guys. Started from the bottom, now we're here. Started from the bottom, now we're here. Started from the bottom, now we're here. Please don't forget, started from the bottom, now we're here with the range. Guys, thank you so much. I think with those words, I now declare class adjourned, session complete, please, as I said, guys, go and subscribe to my YouTube channel. The link is in my bio. https://YouTube at Maths is a Game 5 to 7. The link is in my bio. You can just go and click on there, go to my YouTube channel, okay? And then after you've done that, you can subscribe, please. I would really appreciate that. The video that is a follow, that basically is this one of this lesson, I will be uploading, okay? But it will just take a while because I have to first download it and then upload it. I'll upload it onto that channel. Those who did not get this lesson from the beginning can watch it from the beginning. It's obviously going to be a bit long, but yeah, take some time, watch it. And then tomorrow at 9 p.m. I'll be doing the follow-up lesson on functions. And what are we anticipating to continue with? We will continue then exploring the the hyperbola function and the exponential function. Okay, I just want to close on this note that in summary, the properties for our functions for the straight line, you notice that the domain was x is an element of R, right? You notice that the range was y is an element of R, but there's no turning point for a straight line, of course. Asymptotes don't exist. Axis of symmetry, we don't have any. For our hyperbola, we are going to note these things tomorrow. Generally speaking, if the function is not limited, we are going to note these tomorrow. Asymptotes, we told you, we spoke about these. Axis of symmetry, we are going to get into it for hyperbola when we sketch the function and talk more about it. Then your parabola, we spoke about the domain, generally speaking. Range, this is when our graph is concave up. We do notice this about the range. When the graph is concave down, you should notice that y is always going to be less than whatever the y coordinate of the turning point is. Alright, and vice versa. Okay, note these things. Turning point, of course, we have minus b over 2a to get the x coordinate of the turning point. But to get the corresponding y value, we take the function, okay, and we substitute that x value that we got into the function so we can get the corresponding y value. In some cases, you'll find that you can get the x coordinate of the turning point if ever you are given the x-intercepts of your function. You can find the midpoint of the x coordinate by taking the first x-intercept, adding it to the second one, and dividing by 2. This is like how you guys get your midpoint in analytical geometry, because it's midway. Same thing with the axis of symmetry. It is midway between your x-intercepts, or it is midway between the same y values on the same horizontal line on your function where your x values are situated on the function itself. You can always take those two x values, add them together, and divide by 2. Then substitute the corresponding that x value into the function so that you can get the corresponding y value. Then remember, guys, that turning point that you can read from the turning point form here, you can read your turning point from the turning point form. The inverse of plus p, x coordinate of the turning point, the q value as it is, y coordinate of the turning point. Then asymptote, we don't have any for a parabola. Axis of symmetry, please guys, the formula x is equal to minus b over 2a gives us the equation of the axis of symmetry, which is a vertical line that coincides with the x coordinate of the turning point. Or the inverse, when we are given the turning point form, the inverse of p is the equation of the axis of symmetry. Okay, remember that. Then lastly, for our exponential function, we will see this: the domain, generally speaking, the range, generally speaking, all right, and then lastly, the asymptote, generally speaking. Okay, but we'll be going into detail, but that's just sneak preview. Hopefully you guys can actually, take note of these properties. They are very important. These are summary properties that you need to have, because guys, let me tell you this: This is all. If you remember at the beginning, I said you must make sure that your bucket of knowledge, that I'm pouring the water that is clean of knowledge, that I'm pouring on top of your bucket must not have holes. Your bucket must be sealed watertight. I cannot, when I come back tomorrow, find that the water, some of it that I shared with you today, it's spilled out because you are not being serious about retaining the water in the bucket. Do not open the pail. Don't open the bucket, guys. All right, because if you expose it to too much sun, it will evaporate. The water will go. All right, we need to keep this knowledge, and we need to have the capacity to retain such knowledge for functions for June, for September, for November. If we are writing in May, we need to have the tenacity to retain the knowledge up until then, until we write. And it must be just as good. If you are feeling that it's fresh and I know what I know and the way that I know it, you must know it not just for now, but you must know it for later. All right, so thank you very much for joining in the live lesson. Much appreciated. If there are any farewell gifts, I will kindly take some. I will just close the link at 3:30. You're not 3:30, sorry, 12:30. You see, now I'm crazy. I'm losing my mind. At 12:30, it's 12:25 now, just to allow people to leave, the live lesson, to gravitate to other live things if they want to go and watch entertainment now. But please, guys, find a way to retain this. Okay, the best way to retain it would be to go and do some exercises as well, like that are related to what we covered, so that you can check that your knowledge is actually what it professes to be. Okay, so thank you so much. Love and leave you. So if you do have any sweet showering gifts, whether it be a rose, whether it be an ice cream, whether it be a you awesome guy that aligns with my life goal, I'd be happy to see those fly through, or as a farewell what. So in the next 4 minutes, I'll just kind of like allow the live to, you guys can file out the live. I'll see you guys tomorrow. Thank you so much. It was really a treat. You are the stars. I am not, but you guys are the stars. So thank you so much again. Oh, and thank you for the likes, guys. 19.5k likes. I think that's quite a healthy number of likes. That means a lot of people were double tapping today, that's for sure. So thank you so much for the likes. Much appreciated. Very much appreciated, the likes. Yeah, guys. These were some of the critical notes that we basically utilized today. So I'm just kind of like just giving you a chance to kind of peruse through, do what you need to do, screenshot if you need to, whatever it is. The next 2 minutes I'll be ending the live. Actually in the next 1 minute, few seconds actually, I'll be ending the live. And thank you very much for joining the live. I much appreciate it. I hope you have a wonderful night as well, and that you enjoy yourself. Hopefully school is amazing if you're going to school, but if you're maybe a rewriter and you will be spending some time doing some maths, I hope you will be able to do the maths and do it very well. Thank you so much. I really appreciate all of you. I hope you have an amazing morning and day and everything. Thank you so much. Yeah, in the next 10 seconds, guys, I'll be out. In the next 10 seconds. Okay, thank you so much, guys. Have a great night, and we'll see you again tomorrow. Like I said, don't forget to subscribe to my YouTube channel. Link is in my bio, guys. You can go and click on the link in my bio. Go and subscribe right there so that when I do upload any future videos, yeah, you can get them. Also, if you have, like, I don't know, a brother or sister, uncle, cousin, toy, dog, favorite neighbor, nephew that is doing grade 8, 9 or 10, you can allow them, you can also let them know to actually go and subscribe to my YouTube channel. I have videos, especially for grade 10s, that are starting maths like from scratch, starting maths this year, and they're not familiar with many things. Like, I really have been doing some videos to like support them. So you can go to my playlist in my YouTube channel for trigonometry, for geometry, for any of the term 1 content, and they can go and check out some of the live lessons that I've done. It might be on any aspect. Word problems, for instance, tend to be an elusive topic there. I have an entire video there where I covered and helped explain word problems and so forth. So just let your grade 10s, whether grade 10, 11, 12, 8, 9, there's something for everyone. Generous helping. Okay, thank you so much, and I'll see you again tomorrow.